Okay, friends, so in case this question here threw you for a loop, why is the way in question 9 correct? I'm going to give you two fictitious boxes to show you why the way in question 8 is incorrect. This is actually an old method of argument called reductio ad absurdum, which means you've got two things to choose from. You've got question 8 and question 9. I'm going to show you why question 8 doesn't make sense, which will hopefully explain why question 9 does. Okay, so to do this, I'm going to create two fake boxes. Box A, box B. And we're also going to lean pretty heavily on the definition of what a percentage is. Okay, box A, I'm going to put 96 eggs in it. And of those 96, 95 are going to hatch. Okay? Now, if you do the division on this, the percent live hatches in this box for box A is going to be, whoops, I'll get that later, is going to be 95 out of 96, which is about 99%. That's a pretty good hatch rate. Okay, now box B, I'm going to make this be a much smaller box. We're only going to put 4 eggs in it. We're going to put 4 eggs in it. And of those 4 eggs, only 2 are going to hatch. Okay. So what's the percent live hatches there? Well, that's going to be 2 out of 4, which is 50%. Half of them. Okay. Now, how would we discuss both boxes in total? How would we discuss them? Both. Now, hopefully, logically, the true percentage needs to be somewhere between 99 and 50. Okay, that's the low percentage, this is the high percentage. But where? Where is it going to be? Now let me clean up the board here in a second and then we're going to rediscuss it. Okay, so the way we did it in question 8 was to add a la question number 8 was you add the two percentages together, so 99% plus 50%, and divide by 2. So that's going to be 149 divided by 2, which is, I believe, 74.5%. Check. A la question number number 9, 3. was we do it like we did the Frank, Sean, and the overall hatch rate, which was add up the total number of babies that we got all together. 95 plus 2 is 97. And then 96 plus 4 is 100 total eggs, and that's 97% of a hatch rate. So, I haven't graded your papers yet. But if you look at these two, I'm almost positive you're going to say that is the correct solution method. Notice that 97 is between 99 and 50, which is what it should be. But so is 74.5. It's just that 74.5 is exactly between 99 and 50. And this one is closer to that one than it is to that one. And hopefully that makes sense to you. I hope. This is the correct way for a bunch of reasons. The purely mathematical reason is that the only way you can take an average in this way, adding up and dividing by how many there are, is if every single data point you have is worth the same amount. Now, this goes back kind of to what the definition of percent means. Percent. 99% means that if you maintain this rate with 100 eggs, you'd have 99 out of the 100 hatching. 50% here means the same thing. If you maintain this rate with 100 eggs, then 50 out of the 100 would hatch. But that's the catch, right? These two things are not out of the same number of eggs. This one here is only out of 4, and this one here is only out of 96. That means that this one should be worth more than this one. So there's two ways around that. I'm not going to show you the second way because it's a little more convoluted, but this is the first way. And this goes back to, I said there's many ways to explain why question 9 is the correct way. The main reason is a percent is a part out of a whole. A part out of a whole. That's the whole point of percentages. The part here is the number of babies that hatch. It doesn't matter what box they're in. What matters is how many babies hatched. 97. The whole is the total number of eggs we planted. Again, it doesn't matter which boxes they came out of. We planted 100 total babies. So the reason question 9 is correct and question 8 is not is fairly simple. You can't average percentages unless those percentages are out of the exact same numbers. And these are clearly not. Therefore, box A's percent needs to be worth more than box B's percent. Now, give question 10 a try.